Okay, for the final segment of this video, we'll talk about how to configure access structures. This is something you can do using the setup program, so setup.x. You can see here it allows you to configure a bunch of different things, but for this video I will focus on secret sharing. So actually I already configured, so before I ran the NPC program, I actually already used the setup, and I picked Shamir secret sharing, so I can just show you what I already did before. It's going to ask for modulus, so I picked one for Shamir. It's asking me for modulus. I will just copy this bit prime. This is a 128-bit prime. Enter threshold to be 1, and that's done. And it will show you the access structure matrix here. Now we can do something different and go secret sharing, and instead of Shamir we'll go with replicated. It's going to ask me for the modulus again. Okay, now it's asking how do we want to initialize the access structure. There are different ways to do it. You can select set of unqualified sets or set of qualified sets, or simply give a threshold. In this demo we'll just go with 1. And we need 3 unqualified sets. So these values basically mean the first party is in the unqualified set, the second party is in the unqualified set, and the third party is in the unqualified set. And there are different types of offline phases. I think you saw some of these in Nigel's lecture. Just go with 1, and that's done. We can try to run it as well. Can try to compile it first, and then go back here and run our program. Okay, so that finished. The time it took is pretty much the same as Shamir. So for replicator, it's pretty efficient, as long as the number of players is not too high. Okay. Now let's try something different again. So before it was Shamir and replicator, those can only support a threshold 1, means you can only tolerate 1 adversary. So now let's go with full threshold. So we don't need to enter a prime here, because there are certain requirements for the FHE to work. So that's why there's a way to find one, to ask the program to find one. And bit length, let's go with 128 again. Okay, so that's done. We'll compile it again, and we'll run it again. So this time it will take a lot longer because it's full threshold. And maybe I can just bring up yeah, if I just bring up this top, you can see it's using three players. These three players are using a lot of CPU and using a lot of memory. So that's pretty much all of the memory I have. So now I will just skip ahead a bit, so you don't wait here for too long, and then show you the amount of time it took at the end. Okay, so the program is finishing. You can already see the total time is 245 seconds. So that's over 4 minutes for the online and offline phase, so including pre-processing. And the online phase is 185 seconds, so just over 3 minutes. Now you usually wouldn't run MPC program like this on a single computer. That's one of the reasons why it's taking so long. It's just using all the memory. The serial knowledge proofs and consumes a lot of memory. And another reason is simply the homomorphic encryption operations are just very expensive, and you need these in the full threshold setting. So thank you for watching this demo. I hope you learned something, and good luck programming with MAMBA.